the end of our week. Only one more week to go this year. Okay? All right. So, let me get attendance. Open up your computers. There's been a few questions about your labs. I will answer those questions, then make sure you can get those labs turned in. Then we'll talk about uncertainty today and do a little problem solving today. She's at the door. I don't care. She should knock. She should knock. She knows how to knock. Knock. See, there you go. She knows how to knock. What?
I'll try to be polite.
Well, polite is when you come to a door knock so somebody lets you in.
Well, I did knock. Just didn't hear it.
What?
Yeah.
What?
I did this.
That's not a knock.
It is.
Here. You left this in math class.
Thank you.
You're welcome. Thank you. All right, ladies and gentlemen. So get your computers out. Open up to the lab. If you've turned it in, that's fine. We'll just talk about it. If you need me to hand it back to you real quick, I can. All right? All right. No,
Why did I get so clear?
Quiz. 2, 4, 6.
It's basically a test. Every quiz in that class is a test.
I don't really know what I'm doing in that math class. I don't get it at all. I didn't take enough.
Don't think I understand what's going on.
Okay.
No. He just gives us a lesson and then we do that.
Okay. You can take notes on the lesson.
The lesson that's on paper.
All right. So
Take notes of it.
before we get to the question of the day today, ladies and gentlemen, let's take a look at your lab from yesterday just to make sure we're all on the same page.
That is. It's on the paper.
I don't know why you guys take notes, even though you do.
Are we okay, Brindley?
No.
No? Okay.
I'm not yelling. Just saying incorrect, spreading incorrect information.
Okay. All right. So here's the thing, ladies and gentlemen. When on your lab, when I'm grading it, number one, I'm going to look for the purpose. Hopefully you have the purpose down to find the density of various objects, making proper measurements, and compare them to known values. Then in here, ladies and gentlemen, you should have at least 3 observations of each thing. If you do not have 3 of these boxes filled, it's easy. I go and I highlight it and I put -1 for not being done. So these things should have at least 3 observations in for each of them for all 5 of the objects. Now here, ladies and gentlemen, this table, okay? Couple of things about this table, ladies and gentlemen. Number 1, wasn't a green liquid, should have been a blue liquid. Sorry, please correct that. The only way we can find the mass of the blue liquid is to do mass by difference. Now, some of you might have taken and put your graduated cylinder or the other empty container, Fleeker, on your balance and hit 0. Then poured all the liquid in and measured the mass. That would be absolutely fine. Absolutely nothing wrong with that. If you did that, you should have a mass in here and you don't need this mass by difference. Okay? But as I was explaining to one group, if you do that, one of the bad things about that is while you're using the balance, the group across from you cannot. Not every graduated cylinder, even if they look like they're exactly the same, with the same colors and everything else, are going to be the exact same mass. So if you do that, put this on there, 0 it, the other group can't do anything with that balance until you're done. Because they can't re-0 it for themselves, they can't do anything. In a lab like this, you could probably get that done in a few seconds and it didn't really impact the group across from you. But labs that we do later on in the year, you may not be able to do that too. So we may have to do mass by difference. And that means, ladies and gentlemen, we take the mass of the object empty We put something in it, we take the mass of it with that something in, and we subtract the 2 to get to the difference. Now, one of the things about all of these numbers here, ladies and gentlemen, they should all be to 3 places beyond the decimal. All of them. Okay? That's the place that our balances read to. The other day we did a lab on precision where we learned how to take measurements. The idea now is when you take a measurement, you should make it as precise as you possibly can. Which means these should be to 3 places beyond the decimal. Now, the other thing about it though is when we measured the mass of the cork, that was under 10 grams, correct? So, because of that, when we found the mass of the cork, we only ended up with 4 sig figs here. 5.321, something like that. But when we measured the gray metal object, that had a mass of over 10 grams. So we ended up with 5 sig figs there. If you have something that is over 100 grams, you're going to end up with 6 sig figs. So this is how sig figs can change just by measuring, even with the same instrument. Okay? Now, you're asking, why do we care about sig figs? Well, when we find the density, our sig figs depend on how many sig figs were in your measurement for mass. Down here was where I really saw the problem, ladies and gentlemen, when you were finding your volumes. This is what the graduated cylinder that you use, ladies and gentlemen. This is marked out in the tens place very clearly, 10, 20, all the way up to 100. But between 50 and 60, there are 9 marks. That means you have 51, 52, all the way to 59. So the instrument reads to the ones place. Every measurement you take with this should be to the tenths. Every measurement, okay? Now, if you okay, here's your cylinder. Sorry about my poor drawing, ladies and gentlemen. There's the level of the water. This mark right here is 35, let's say. Here's the next mark for 36. You get to estimate where in between those 2 marks you think that liquid is. Okay? So, looking at this drawing, where would you say the bottom of that line is compared to 35 and 36? What would you say it would be? You get to pick the tenths place. What would you pick, ladies and gentlemen? You could do 35.3. You could do 35.5. You could even do 35.6. Anywhere in there. You get to pick that last number. Okay? Now, the only thing I wouldn't do is I wouldn't do 35.0 because it's not really close to 35, and I wouldn't do 36.0. Now, the problem becomes, ladies and gentlemen, sometimes our lines get very close together. Bless you. Here's the line. There's the line. There's the line. Okay? And then when your liquid comes out to be very close to that line, now let's say that line is 35 again. This line up here is 36, and this one down here is 34. It becomes much harder to estimate. I have no question there. But because this is still reading to the ones place, you have to make sure that your measurement ends up in the tenths. Okay? Because these are in the ones place, these were in the ones, our measurement needs to end up in the tenths. So again, you can do 35.0. When your marks are close together, it's going to be hard for somebody to argue with you. Okay? And no one is going to argue with you. But if I look at your measurements in here, ladies and gentlemen, in this table, and they are not to the tenths, I can mark them wrong. Okay? I can mark them wrong. So if you have measurements in here that are not to the tenths, you shouldn't do this, but I'm telling you, make point zeros on every one of them. Make point zeros on every one of them so they at least go to the tenths place. Okay? Now, if you have a number in here, let's do 36.0 minus 28.0. What is the volume of this object?
7 milliliters.
No.
My bad.
8.0. Please remember, when we are subtracting these, since they are both to the tenths place, your final answer needs to be to the tenths place. Okay? Those are our rules for addition and subtraction with sig figs. You find the least precise measurement. Well, here's the good news. All of these have the same precision. They all read to the tenths place. So every number here should be to the tenths place. Now again, how many sig figs in this number? 2. Well, over here, maybe you had a number like 86.0. How many sig figs in that? So your sig figs can vary depending on the size of whatever you are measuring. But we need to know sig figs because when you find density, we're going to take a number with a certain amount of sig figs divided by another number with a certain amount of sig figs, and then we are going to have to round our final answer. Okay? We are going to have to round our final answer. Here's the other thing. To find the density of the gray metal object, you are taking the mass in this box right here divided by the volume in this box right here, and that will give you density. It is equal to mass divided by volume. Okay? So we're going to take these two and we are going to divide them. Questions? Now, down here, you came up with numbers. Okay? You came up with numbers. What kind of unit should your numbers have? Your unit should be grams per milliliter, just like I have over here. Now, since I put the units at the top in this last column, ladies and gentlemen, here are my units. I don't need to put them by each and every number. So you have two choices here, ladies and gentlemen. Next to every one of your numbers, you can put units. Or you can go up here and you can change this where it says with units to be grams per milliliter, just like I have here. But you have to somehow give me units for each one of these numbers. Okay? Now, here's the other thing I will tell you. We're not doing it with this lab. But if we were graphing these, then you would have to put the unit up here. Why? When you graph things, graphs can only work with numbers. If you put letters in them, they will not be able to graph it. Graphs do not understand how to graph letters. Okay? They only understand how to graph numbers. So that is why a lot of times on tables you will see the units up at the top. Questions? Now for your conclusion, ladies and gentlemen, what I'm asking you to do is look at how this number that you calculated here compares to this number. How this number that you calculated here compares to this number. How these numbers all compare to each other. And then in your conclusion, summarize that. So if 3 of them were very close, my numbers were very close for the block, the liquid, and the rod. But for the cork and the gray metal object, they were way off. That's what you tell me in your conclusion. But then also give me some data. So my numbers for the block, the liquid, and the rod were very close. Now you could do a couple of things. You could take any one set of them and say, well, I got 2.69 and it was supposed to be 2.70. Or you could say, you know what, they were only off by 0.3, 0.2, whatever the difference between them is. Okay? So the biggest difference was 0.5 in one of my measurements. That's fine. That's data. You're giving me that. And then tell me in the ones that it was way off, well, my gray metal block was, I got 18. It was supposed to be 11.4. That's fine. Something like that will work. Okay? That is what you do in your conclusion, ladies and gentlemen. By the way, is there anyone who turned in their lab who needs it back?
Can't you just unsubmit it?
I don't know if you can at this time.
We can.
You can? I don't know how long you can unsubmit till.
Yeah,
Yeah, I think you could just unsubmit.
Oh, they used to say that if you submitted it after again, I don't know because I've never been on your side of Google Classroom, but I used to have kids tell me they couldn't unsubmit things. Maybe if I start grading them, you can't unsubmit. I don't know. I don't. As long as you can do it, that's fine. If you needed it returned, I would return it to you. Okay? So any questions on the lab at all? So in here, ladies and gentlemen, some of these numbers are probably going to be to 2 sig figs, and some are going to be to 3 sig figs. The reason being, it depends on if your volume, which is what limits our sig figs in this, because we get at least 4, maybe 5 sig figs from the balance, but from our volumes up above, we only get 2 or maybe 3 sig figs. That limits the sig figs in your final answer in here. Now, somebody asked me the question yesterday, well, Mr. Brand, why if I can only go to 2 sig figs is this number to 3? Well, because when I looked it up online and got that number, that means that whoever made this measurement or whoever found this value had instruments that might have been more precise than we did. Or they used something that was a little bit different than we did. Okay? So maybe they had a graduated cylinder that read to the 100th place. Maybe they found it by using length times width times height, and they could do it that way. I don't know for sure. Okay? But in science, I do know that whoever made this number, this measurement, their precision was to 3 places, 3 sig figs total. Okay? I do know that. Okay? Questions? All right. Okay. Does anyone need a few minutes to finish the lab up? All right. We'll give you a couple minutes. Please get it finished. Please turn it in. If you're done, you can open up your EISN and get to near the end of it. We're going to talk about uncertainty today.
Could you help with the question?
Okay, which one?
All of it.
All of them. Okay, what's the first question?
Why is it necessary to find mass by difference for some?
Okay, I was just going to talk about that, so let's talk about that. Okay? Here's an object. If I want to find the mass of this object, what do I do? Just put it on the scale. It's solid. I can pick it up. I can put it on there. I put it on the scale. It'll tell me the mass. Now, I might have one problem with this object on the scale.
It'll roll off.
It might roll off. So if that were the case, I would have to put something else on the scale and put this in it, correct?
Then you don't get out your weight.
Well, I only want the mass of this object. So that may be a case of where I have to do mass by difference.
If you can't zero the scale.
If you can't zero the scale, yes. Okay. Now, again, a lot of times you could zero the scale. Absolutely. But we're going to do a lab in here later this year. Okay. Where we are going to take and we're going to find the mass of a dish. We're going to put some zinc in the dish. We're going to find the mass of the dish and the zinc. Then we're going to do a reaction in the dish. We're going to put hydrochloric acid with the zinc. We're going to make a compound called zinc chloride. It's a salt. We're then going to take and we're going to put the dish on a hot plate and we are going to evaporate or boil off all of the water so that we are left with just the salt. This lab is going to take you about 50 to 60 minutes, maybe longer, okay? Now, if you put your dish on the balance and zero it, then you can take your dish, when you have the zinc in there, you can put it on there, you can find just the mass of the zinc. At the end, you could find just the mass of the salt. But no one can come over and use your balance while you're doing that. Because if they put their dish on there and zero it, you've lost your zeroing. You understand what I mean? Because not every dish is going to be the same. So in a lab like that, I can't let you tie up the balance for the whole hour and the group next to you not be able to take any masses. So there we're going to have to do mass by difference. Okay? There's another lab where we find the mass of an object one day, we put it in a drying oven overnight and find the mass of it the next day. Well, our balance wouldn't stay zeroed for that long. Okay? So we can't always do the zeroing, just so we know. And if that's the case, we may have to do mass by difference. Now, sometimes it's because we can't tie the balance up for that long. But the other reason we need to do mass by difference is there's no way to find the mass of a liquid without it being in some container. Okay? There's no way to do it. So even if we zero it with this object on there, we're technically still doing mass by difference. Okay? It's just we're letting the balance do the subtraction for us. Okay? The same thing would be true if you had like salt. You're not going to pour salt on the tray and then mass it and then use it because you would have a hard time getting all of that salt back into whatever you want to put it in. So you're going to put it in a dish. So sometimes we have to do mass by difference. Okay? Now, someone else asked me this morning about the other question, which was, why do we have to do volume by displacement? Right? Okay. What shape is this? Can we do that mathematically? Very easily, right? Shape. Sphere. Can we do that very easily? Yes. What shape is this? It doesn't really have a single shape, does it?
No.
This is kind of circular, okay? Kind of like a cylinder almost, right? But it has this odd shape over here. What about something like this? There is no set shape to it. Or something like this. Okay, we can look at this and say, well, this is starting out to be like a cone, right? But then all of a sudden we have this wavy part at the top and we have a hole in it. How do we find the volume of something like this mathematically? You could drive yourself nuts trying to figure it out. But if we take this object, we drop it into water, see how much the water goes up? we can find the volume of it very easily. So volume by displacement is an easy way to find the volume. And it even works with something that is like those rods. It even works with those. I mean, you could do that mathematically. But it almost is just as easy to drop it in water, see how much the water goes up, and measure it. Okay? Now, I wouldn't do it with a beaker. Why? Beakers aren't very precise. Beakers are marked out in 10, 20, 30. That doesn't really help us get a very precise measurement. Okay? So we always want to try to find the most precise way to take a measurement. And a lot of times we could do it with volume by displacement. But the reason we have to do volume by displacement at times is it's the only way to find the volume of a certain object because it's just not regularly shaped. Okay? Just not regularly shaped. Questions? I think that was the only two questions, correct?
There's a third one.
What's the third one?
What kind of observations should be reproducible in one?
Okay, so
Quantitative.
what's it?
Quantitative.
Why?
Because it includes a number and you make a measurement, it should be accurate.
I hand this to 5 of you, say go to a balance and find me the mass. You should all come back with it. I ask you what color this is, and 5 of you might give me 5 different shades of blue. So again, a quantitative observation, when it's numbers, when we're using an instrument, should be reproducible. A qualitative observation, the burnt orange sienna color of Leaf's sleeves, not everybody may see it that way. So quantitatively, we should all come up with the same numbers. Qualitatively, we may differ on things. You may say something smells good. I may say something smells bad. Now, we're not arguing on the odor, but we're arguing on what, our interpretation of the odor. Okay? You shouldn't be arguing over numbers. Okay? So again, there were a few times where I went to a group's lab and I'm like, how come they have different numbers than you when you're working on this together? You should have the same numbers. Okay? Questions? Okay. So again, anyone need more time on the lab? Okay. All right. I hope that helped, ladies and gentlemen. And please, don't be afraid to ask questions. I will help you with things. Yes, Rocio. Can you get a charger? I will go back and grab you one. All right. While I'm doing that, please open up your EISNs, ladies and gentlemen. Let's talk about uncertainty. Okay. So, with uncertainty, ladies and gentlemen, there are 3 things shown in every measurement. Every measurement that is ever made, 3 things are shown. The quantity, the number. The unit, what you measure. And uncertainty/precision. Uncertainty/precision is shown in every measurement. So when I look at a measurement that Levi makes, I can see his number, I can see his unit, and I can see uncertainty and precision. But you have to know what you're looking for to find uncertainty and precision, ladies and gentlemen. And that is what we are going to talk about. Uncertainty in a measurement is always found in the last sig fig. Always found in the last sig fig, which 99.9% of the time will be the last digit, unless the last digit happens to be a 0. And it will still be good if it's a 0 if there's a what in the number? A decimal. So the only time uncertainty is not the last digit of a number is if it ends in a 0 and there is no decimal. If it ends in a 0 and there is no decimal, the 0 is not the last sig fig. Otherwise, any other time it is. Any other time it is. So, the uncertainty is in the number that you get to estimate. So a couple days ago, we asked you to use this instrument to measure the width of a box, right? This reads in the ones place, ones. So your measurement goes to the tenths. So let's measure how tall this desk is with this instrument. From here to my finger is how tall that desk is. So we know it is less than 1, but more than 0, correct? So when we estimate where my finger is here, is it more than half? Okay, so we need a number that is more than half. Is it right near the top of the stick or right near the end of the stick? So we probably can't say 0.9 or 0.8, right? So what do we estimate this to be? About how much? 0.6, 0.7. Maybe even I would let you get away with 0.8. Okay? But you get to estimate that. Are we sure about that number?
No.
No. That's uncertainty, ladies and gentlemen. That is uncertainty. Now, this is not a good instrument to take a measurement with because it reads in the ones place. It's not very precise. Okay? But uncertainty always falls in your last sig fig. So the best you could do for that measurement would say 0.6, 0.7 meters. Uncertainty falls with that 0.6 or 0.7 because that's the number that Miro picked. Okay? That is uncertainty. Now, even when we go to an instrument that may be a little bit more precise, this is now marked out in tenths. So now we put it here. We go here. Now my finger is between what two numbers on here? 0.7 and 0.8. So because this is reading in the tenths, we get to go to the hundredths. So now you're going to say 0.7 what? 0.73, 0.72. That 0.72, that 0.73, that 2 and that 3 are still the uncertain digit. Still the uncertain digit. Why? Because we don't have a line there to show if it's actually one or the other. We're estimating it. So every time you take a measurement, uncertainty falls in the last sig fig. Now again, what if the height came out to be right at 0.7? We could call it 0.70, but we're estimating the 0 still. Okay? And that's what we mean by uncertainty in a measurement. You're estimating that last place. You're not sure of it. Okay? Even with a very fine instrument. Okay? This one reads to the thousandths place. We can report an answer to the 10,000ths, but that 10,000ths place, we're still estimating it. So it is still uncertain. Now in a digital instrument, it'll be the last digit. It'll be the last digit. Now we don't get to see how close the number after it is. So uncertainty always falls in that last sig fig. So when you look at a number, ladies and gentlemen, 3.36, what's the last sig fig in here? The 6. Okay? That's the last sig fig. It's also the uncertain digit. Now what this also tells me, now again, assuming that this is not a digital instrument, and you have no way of knowing if it's a digital instrument or not, what place did this instrument read to? The tenths. Why?
Because you're estimating the one place after it.
You're estimating the one place after it. So looking at that measurement, I can tell that this instrument read to the tenths place. And you are estimating one place beyond there. Okay? So that's what we mean when we say the measurement shows both uncertainty and precision. This instrument must have read to the tenths because you're reporting it to the hundredths. Over here, what place did this instrument read to? The hundredths, because our answer is to the thousandths, or our measurement is to the thousandths. So we go back one place. That's how we find the precision of the instrument. Now, what's the last sig fig in this number?
0.
The second one.
The second 0. Okay, and I'm sorry, I should have explained that first. These zeros are both significant. Why? Because there's a decimal here. The last one is the last sig fig. So that is also the uncertain digit. Okay, it is also the uncertain digit. And you can estimate that digit as 0, which is why when I told you to go back and switch all your volumes to 0.0, you can do that. You can estimate that last place as a 0. It's okay. Questions? All right. So the number 0.0209. Jen, what is the last sig fig in this number? Which digit is the last sig fig? What's it? Yes. No, that's fine. I just was taking a drink. Sorry, that's why I didn't answer right away. The 9 is the last sig fig. So the 9 also shows the uncertainty. It shows the uncertainty. Now, how many places beyond the decimal is the 9? To the 10,000s. So what place would this instrument have read to, assuming it's not digital? To the thousands. One place to the left of that. When we make a measurement, we go one place to the right. When we're looking for the precision of an instrument, we go back one place to the left. Okay? Now, 1,400 meters. What do we know about the zeros at the end here? They are not significant. So where is the last sig fig in this number, Jacqueline? In 14,000, or 1,400, sorry, which digit is the last sig fig? 4. The 4 is the last sig fig. So that is also the spot of uncertainty. Okay? But what place is the 4 in here? The 100s. So what place did this instrument read to? It read to the thousands place. And we are estimating this number. We're estimating this number, ladies and gentlemen. Okay? So we can tell the precision of that instrument that way. Now, again, hang on one second here, ladies and gentlemen. I know that was in meters. This is in volume. I would never measure something with this instrument because look at the numbers that are on it. Brindley, can you read me the numbers that you see?
800, 1,200, 1,600, and 2,000.
Okay, so first of all, that's not even reading in the hundreds place, right? And well, there is a mark between 800 and 1,200. What would that be?
1,000.
Okay, and that's the same number, but okay, I don't like 1,000, but
Yeah, no,
1,000.
I didn't like it after I said
No, that's fine. So this is reading every 200. 800, 1,000, 1,200, 1,400, 1,600, 1,800, 2,000. So what place is this instrument actually reading in? Thousands. Here's 1,000 here. Here's 2,000 there. This instrument's reading in the thousands place. Probably not the best instrument to make a measurement in because what is the place that we could report a measurement to in this? No. Thousands. 1,000. The place that is just to the left of that or to the right of that is the hundreds place. So this instrument does, the best you could do is in the hundreds place, just like that measurement that we have there. Okay? But again, you're not going to use this to measure something out. You're using this to store that, and then you have an idea of how much is in there. I wouldn't take a measurement with this. Okay? And that happens with some instruments, ladies and gentlemen. So while this may seem kind of weird to you, well, what instrument would you use to measure in the thousands place? There's one right there. It does measure in the thousands place. Okay? Questions? All right. So here's what I would like you to do. On this slide, and I know it's not 93 in your notes. What slide is it in your notes? 82. Tell me what the last sig fig in each of these measurements is. That I hope you can do. tell me what the uncertain digit is after you tell me what the last sig fig is. That you should be able to do because what do we know? These are they're the same. When you find the last sig fig, you found the uncertain digit. And then try to tell me the place that this measurement, the instrument read to. Try to find the place that that instrument read to, please. Take a couple minutes. Please get that done. Okay? Take a couple minutes, get that done. If you have questions, call me over. I will be happy to stop by and try to help you. Okay? So, for example, when I say the place the instrument reads to, this instrument reads to the tenths. Now, how will I know that? Well, because when you take a measurement with this instrument, your measurement will be to the hundredths place, one beyond that. So once we know where the last sig fig is, we go back one spot, and that will tell us what place that instrument read to. Okay? Leave.
Oh, could I grab my water bottle? I'm done with the tea.
Go ahead.
Where is the zeros at the end? Oh my god, it's the last line.
Okay, if you volunteer early, you get your choice of whichever one you want to do. Smart move, Brenda. Smart move. Who?
Wait, do we have to do all the?
Oh!
But we have to do all three.
No, just do one. Fill in any one box you want. Any one box you want, then give your marker to somebody else.
Oh.
Nadia, you play soccer? Yeah, I could tell by the way you caught it. I'm kidding. I'm kidding. Yeah, the way you caught the marker when I threw it at you. You got hands like a fish.
Here it is.
The zero is even big because there's a decimal.
Oh, I like that, Isha. Take the tough one. Take the tough one. Don't go with those easy ones of the last sig fig. Take the tough one.
Yeah, like,
Pick a different one if you want.
No, it's okay. My hands are just nice.
come on, Nero. Our next what?
You want me to open it?
I don't know.
Oh my God! Who gave you the unopenable one?
Like, oh, probably.
Jeez.
Oh, yeah, I want to do
I'm
that.
not gonna close this.
Yeah.
Look at that! People volunteering and everything just so that they don't get stuck with the ones at the end.
That's right.
I don't know why that marker was so hard to open.
Cynthia, she cut you off.
I did.
You're gonna take that, Cynthia? She cut you off.
I did. I'm sorry. I'm sorry. That's what. Did you go? Yeah, I did. You're lying. I did. You're lying. Like, I'm lying.
It doesn't matter if she went. Give it back to
Oh,
her.
that's true. That's true.
Oh, she gave it right back
oh
to
my
you.
God. I'd be so done.
Or you could give it to me.
Oh.
Sorry. What? What does a cat look like? I can't believe you have that bad balance. Really, are you actually?
I can't believe you would treat an old person that way.
Oh, no. You said it. I thought you said that.
No, I gave it to you.
Well, I might as well be accurate in my description, correct?
You
You.
gave it to Levi.
I gave it to
Sorry.
you.
Sorry.
How dare you.
You're gonna get it back. Levi, don't. Levi, like.
Oh, don't let her talk you out of it. If you want to give it to her, you give it to her. She comes up here then. She comes up here. Jen, Aiden, you guys played this well.
I don't know these.
Sit in the corner, be quiet, don't say a word. Nobody brings you anything. You guys are good to go. Good to go. Oh, look at Jasmine too. Jasmine's like, I'm gonna stay here until the last person goes up there so that I don't have to go. Thank you, Jara. You don't have that last part done? Well, that's okay, because that honestly is the hardest part. Here, I'll take the marker from you, please. Thank you very much. Okay? All right, let's look at these and make sure they're correct, ladies and gentlemen. Okay. All right. So, in the first one, the last sig fig is the 3 here. The uncertain digit is the 3. Now, because our number goes all the way to the hundredths place, it means the instrument that was used to take the measurement only went to the tenths place. Now, again, ladies and gentlemen, I applaud you. I do not like writing these out like this. You guys do. That is great. I would have done this with this. That is another way of expressing the tenths place. Absolutely nothing wrong with what you did. But again, sometimes it's very difficult when we are talking, speaking, to differentiate between tens and tenths. So you just have to be careful, okay? Good. Perfect. The 8 is the last sig fig here because the zeros are not significant. Again, it is also the uncertain digit. And again, thousands place, correct. This is the number that is just to the left of the 8. That means this instrument read to the thousands place, ladies and gentlemen. And I would have written it like that, but again, absolutely nothing wrong with what you did. Okay? The 0 is the last sig fig here. Why? Because of the decimal point. The 0 is also the uncertain digit. Last sig fig is always the uncertain digit. On your test on Tuesday, you are going to be asked this. This is an easy 5 points for you. Or it will be 5 points that you forget to do because you don't identify which one is the last sig fig. This 0 is in the thousands place, so the measurement, the instrument had to read to the hundredths place. Perfect. Whoa, 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 whoa. You let me get away with that?
Yep.
That's the hundredths place. I wrote the hundredths, sorry. The 2 is the last sig fig here. The 2 is the uncertain digit. The instrument read to the hundredths place because the 2 is in the thousands. Perfect, ladies and gentlemen. Okay? The 0 is the last sig fig. That's the reason we put the decimal here, to make the 0 significant. So the 0 is also the uncertain digit. Since the 0 is in the ones place, the instrument that we use read to the tens. Perfect. Okay. And then finally, 7.00. Again, the zeros are significant, both of them, because of the decimal. So the only thing I would have done here, the last 0, just so we're sure of it, okay? I'm assuming that's what you meant because that's right. Which also means this is the last 0, okay? Tenths place is correct because the last 0 is in the hundredths, ladies and gentlemen. Good. Questions? Any at all? I will tell you this is on your test next week, Tuesday. So any questions at all? Anything that you have? All right, ladies and gentlemen, close your computers.
What do you order when you order these? Because I didn't get any of the cute little filled ones, or this
I
is the
order
garbage
assorted.
I get. I got assorted. What is this crap?
Don't ask me. Why are you asking me?
I don't know. Emily was sad because
What
we
was that
didn't
for?
have. We're back there.
Oh, good. Then here,
You
I
can-
want one at the bottom, but I don't want to dig in.
Go for it.
There we go.
Emily was sad that you didn't bring donuts today, so
I don't bring donuts on Friday because I figure people sometimes get them.
Oh, but then I needed to, satisfy her expectations. But
Oh,
I saw Paris. Paris checked me out.
You literally.
So wait a minute, now I'm getting yelled at because I don't buy donuts for the whole department?
But I wanted to know what you get because usually you
I
get
just
those
go
like.
with assorted.
Where are the blueberry ones? Where are the cute little?
Oh, we don't want the blueberry ones. Let's not try to make this stuff healthy. We're eating donuts.
Anyway.
Ugh.
I know, I'm sorry. I just was putting myself away. I didn't really know. Like it was right here, and I needed to put my notebooks in there, so I just put it in my hand.
Here, Rosa. Leave!
Yeah, I normally do it too, but I got yelled at one time.
Nope, all the way.
All right, you're gonna need a calculator too, ladies and gentlemen, so I'm sorry I told you that. If you have one, take one up.
You gave us an extra one, I gave them that, and then they just
So
did
you
it.
were just no person on the pole. All right.
How many times have been told that?
How many?
I don't know. A lot.
I'm just wondering. Okay. I just wanted to let you know in case you weren't aware of it. Okay. All right, ladies and gentlemen. So one of the things that we are going to use in this class often, and we will get into it a lot more later in the year, is we're going to use unit conversion. Okay. Now we kind of did this a little bit when we did the metric system. Okay. Now again, I'm going through this because we have a little bit of time here. On Monday, we will review for our test that will be on Tuesday. This stuff will not be on your test unless it's in the form of the metric conversions that we already did on the first quiz or on the second quiz. You remember when we did that? Unfortunately that you remember, or unfortunately that we did it? Oh, okay. Well, good to know you guys hate my quizzes. You're going to hate my tests even more then. But that's okay.
For everything.
What?
There's a first time for everything.
There's a first time for everything? It's not the first time people have hated things that I've done. Okay? I'm married. Trust me. Okay. So here we go, ladies and gentlemen. All right. All right. So here's the key to problem solving, ladies and gentlemen. The key to problem solving is a few things. Okay? Now, in physical science, our physical science teachers do an excellent job, because I used to be one and I taught them how to do this. They do an excellent job of going through a 5-step process. Now, I'm not going to require you to always do a 5-step process, but there are certain things that you should know when you look at a problem. Number one, you need to have a starting point. Okay? So a problem will say convert this into this. Your starting point is what you begin with. Now, here's the thing about a starting point. Sometimes it is known, sometimes it is not. There are some problems where it doesn't say take this and convert it into this. Okay? Number two, you need to know an ending point. So what unit are you trying to end up in? Okay? Number three, you need to know some conversions. If we are going to go from one unit to another, you have to be given some information. Now, sometimes those are just known facts. For example, how many quarts are there in a gallon? 4. That is a known fact. How many inches in a foot? 12. Okay? How many elephants fit on a train car? Correct. So someone may have to tell you that every train car can hold three elephants. Once you know that, you can use it. Also, please be careful. How many days are there in a week? 7. How many school days or work days in a week? Normally that is 5. Okay? So again, depending on what they're talking about, even though we know there are 7 days in a week, there may only be 5 school days in a week, or there may only be 4 work days. Maybe they work 4 10-hour days. You cannot be expected to know that unless it is standard. So again, if you get something like that and you're unsure, please ask, and I would have to clarify for you. Okay? All right? So these are the 3 things we need: a starting point, an ending point, and we need some conversions. So let's take a look at the first question that is there, ladies and gentlemen. Okay? Uh-oh. Mr. Braham. I do. Yep. Sure. Okay, bye. Jasmine. They need to see you in the Career Center. Okay? So. All right. For number 1, how many feet are in 2.80 miles? Okay, what's our starting point? 2.8 miles. This is our starting point. Yes, Brindley.
I have to leave at, me and Levi have to leave at 8:30. We have class. We have to go to the Career Center.
What? You're right.
Yes.
You're right. Take Jasmine with you.
For now.
Well, yeah. And then Yvonne, you're supposed to go too? I got a smart pass for you here for...
I'll just go.
Okay, hey, anything I can do to get out of Mr. Brand's class, I'm going. I'm out of here. All right, go ahead. Go, you 3. Come on, Levi, go. Come on, Levi. Levi, she wants to leave. Let's go. Levi. Some people, huh, Brindley? Some people. All right. So again, ladies and gentlemen, 2.8 miles, that is our starting point. All right, what unit do we want to finish in? This is our ending point. Okay? And then this is a conversion that will probably help us get there, ladies and gentlemen. Now, here's the one thing I want to point out. Unlike with the metric conversions where we were just sliding a decimal, that isn't happening anymore. That is not happening anymore. So we begin by taking our starting point, 2.80 miles. And we're going to take it times the conversion factor, which is a fraction, which means I can take this and I can either do this. I can put 5,280 feet on the top and put 1 mile on the bottom. Or I can put 1 mile on the top and I can put 5,280 feet on the bottom. It doesn't matter which one I do. But there's only one of them that I can use. Which one? Why the first one? Because we're in the unit of miles here, ladies and gentlemen, I need miles on the bottom of this fraction to cancel out. So this is the one that I'm going to have to choose. So 5,280 feet go on the top. 1 mile goes on the bottom. Miles and miles cancel out. The unit that I'm left with is feet, which is good because that's what I wanted my ending point to be, is feet. Okay? So now you take 2.80. Do we multiply by 5,280 or divide? Multiply. Now, here's the other thing. How many sig figs in 2.80? 3. So how many sig figs are going to be in our answer? 3. Okay? So someone tell me what we get out of the calculator when we take 2.80 times 5,280.
14,784.
Okay. Now that is our number in feet. That's the number our calculator gave us. That's great. But now I need to put this into 3 sig figs. So how do I do that? Okay. You're right on your rounding, but if I leave this as 148, I can't put. Okay, slow down. Slow down, Haley. You've got the right idea. We need some zeros in there, right? Do we want the zeros to be significant? No. So I can put in the 2 zeros in the place of the 8 and the 4. They are not significant, but they do hold the value. They do hold the value, okay? And that is in feet.
So you wouldn't round when you can?
I did round. I rounded to this place right there. I did round. Okay. So, yeah. And you know what? From here on out, after this unit, sig figs are going to be that easy. You're going to look at how many there are in your problem, and your final answer, you're going to put them in that, because most of the time we're going to be doing multiplication and division. And that's what we're doing here. Okay? That's what we're doing here. Question. Okay. How many seconds are in the month of January?
I don't know.
I don't either. Seconds, though, is our what? Nope. That's our ending point. That's what we want to be in. Okay? What is our starting point?
A month or 31 days.
Okay, what do we know about the month of January?
There's 31 days.
31 days. Now, do they give us any conversions here? Okay, do we know any conversions to get from days to seconds? What?
Well, not days to seconds.
Okay, do we know anything about days that we can use to get closer to seconds? Okay, what about hours?
1 day is 24 hours.
So what goes where? 24 hours on top or bottom? Yep, 24 hours on top. Sorry, my bad. So then what goes on the bottom? 1 day. So sometimes they're not going to give you conversions because they'll assume that you know them. Okay, this would get us into hours, correct? But we still want to get to seconds. So what now? Okay, how many minutes in an hour? Okay, which one goes on top? 60 minutes or 1 hour? Minutes on top. 1 hour on the bottom. Okay, that would get us into minutes. So then what?
60 seconds in a minute.
So what goes where?
Seconds on top, minutes on bottom.
60 seconds on top, 1 minute on the bottom. Okay, so now you're going to take 31 times 24 times 60 times 60. What do we get? An answer. Good.
2,678,400
What's the unit?
seconds.
Okay.
Spaces in there?
You don't. You can if it makes it easier for you. Now, the other thing is there anything in here that tells us how many sig figs?
No.
No. So we're going to leave all of these sig figs there. We're going to leave them all there. There's nothing in this problem that was actually measured to limit our sig figs. so we can leave them all in this problem. Questions? Yes, no, maybe so. Now, does anyone know how many seconds are in an hour?
No.
Some people know that there are 3,600 seconds in 1 hour. And if you know that, you could use that in place of these two. Okay? My point being, you might know a conversion that somebody else isn't aware of. And as long as that conversion is accurate, I have no problem with you using it. But the first part of that sentence was, as long as that conversion is accurate. So you can't be like, well, I think there's 5,100 feet in a mile. No, there's not. You can't do that. Okay? Can't do that. You've got to be accurate with your conversion. Questions? All right, let's take a look at the last one, ladies and gentlemen. How many ounces are in 2.31 gallons? Okay, so I'm going to go from gallons. This is my starting point. 2 ounces. This is my ending point. Now I'm going to check here. Here are some facts that they give us. Okay, so we're starting out in gallons. So I'm going to have to use this one, right? It has gallons. That would get me into what unit? Quarts. Okay. Now, quarts could also get me into what? Pints can get me into. So I've got everything I need here, ladies and gentlemen. Okay? I've got everything I need. So 2.31 gallons. All right, there's only one here that has gallons in it. Where does gallons have to go? Top or bottom? On the bottom. 1 gallon. 4 quarts. Okay, now I need something else that involves quarts because gallons have canceled here. What do we got for quarts? 1 quart on the bottom, 2 pints on the top. Good. Quarts and quarts cancel. Okay, how do I get rid of pints? 1 pint on the bottom. 16 ounces on top. Okay. Now, again, if you knew that 1 quart equals 32 ounces, you could have used that. Okay. You could have used that. Okay. Pints cancel out here. Pints cancel out. The unit that we're left with is ounces. How many sig figs? 3. So take 2.31 times 4. Times 2 times 16. 295.6. Okay. Yep. Okay. That's what I was going for. I was looking at the number right after the 5 to see if I rounded it up. 295.6 means, yes, round the 5 up to a 6. Okay. Questions, ladies and gentlemen? Now, again, this will not be on your test, okay? But we will do this from here on out a lot. So I just wanted to introduce it to you. Questions, comments, suggestions that don't involve me leaving the room or killing anyone in it? Okay, good. Monday, ladies and gentlemen. If you have questions that you want me to go over, things that you want me to clarify before the test, that's your last chance. Because on Tuesday when you come in, we're going to be doing the test right away, ladies and gentlemen. Right away.